Hello everyone, my name is Briska Diari Ahmed, and today I'm going to present you every detail and concept about what's the project, why it's important, and how it works. Thank you for listening to this video. My supervisor is Mr. Karzan Hussein, and my project is anti-theft warning system using IOT in parking area. This project introduced the ultimate solution for protecting your vehicle from theft with advanced features such as GSM and GPS tracking, contacting owner, and reporting the police. This system ensures that your car is always secure, no matter where you are. So, by using this system, you can say goodbye to the worries of car theft and hello to peace of mind with the anti-theft alarm system using IoT in parking area. This system aims to provide anti-theft warning system using Arduino by parking the vehicle in a public place such as roads and urbans or near city center. You put the risk of the car being stolen to maximum once that the car is parked. The system expands security mechanism with an anti-theft alarm. This would allow the user to monitor their car location at all time, making sure that the car is staying at the park location without any movement. In case the car was being stolen, multiple security mechanism and protocol would take place. One is notifying the users through WhatsApp, SMS, as well as mobile application. Secondly, then the system would ask the user if they want to report the incident to the police station. If they choose yes, the system automatically reports the police station about the movement and provides them with the direct location of the car. Therefore, they could stop the process and return the car to the owner. Also, problem background. There has been a tremendous growth in the number of vehicles on roads and in urban in the past few years, but unfortunately, the theft of vehicle is a major concern for car owners around the world. In addition to the financial loss, the emotional toll of having a vehicle stolen can be significant. So, as I said, as the number of vehicles grows, the report of stolen vehicle increases parallelly. This has caused $1 billion worth of damage of victims, according to National Crime Information Center. The data warn us about highly dangerous issues in the field, and this is where our proposed system would shine. Even though we might not be able to eliminate vehicle theft completely, the system could potentially reduce the number vastly. Before we get into detail, before we get into detail, now I will talk about the vehicle that are stolen. In most of the reports, the vehicle were stolen overnight or when the theft and more than 2 hours. So to do the means, the times play an important role in this process. The more time the theft has, the harder it makes to locate the vehicle, because once the vehicle is stolen, the theft would disassemble the vehicle and sell the different part of the vehicle separately, rather than as a normal vehicle together. With a proper system, the theft will not have enough time to steal the car, because once the car starts to move, the system would notify the user about the incident, and then the user could report it to the police in a matter of a few minutes. Therefore, the system could stop the vehicle from being stolen and gone forever. And the project aim is, the main goal of this project is to create and develop a user-friendly, responsive anti-theft warning system for vehicle using IoT in parking areas. This system serves as a platform for users to help drivers to park their vehicles safely. Also, we have 4 objectives for this system. First, to design a system and develop a user-friendly system for users, to implement an efficient system to reduce vehicle theft and vehicle in a secure condition, to provide the capability for users to automatically report unwanted vehicle movement, to share the direct location of the vehicle to the law enforcement agency. Also, we have 4 case study based on the literature review. The first case study is vehicle anti-theft tracking system based on the Internet of Things IOT. The project showcased a system which provides the tracking functionality. This project tracks down vehicle theft. The GSM is the component that connects the DC motor to the GPS. The ESP8266 wireless module, GPS and GSM connection were used to pinpoint the location of a vehicle. As a satellite-based navigation system, a GPS system can precisely locate car in any weather. Also, we have another case study, a Bolt IoT-based automobile anti-theft system. According to the author Surya Saha, because of the global epidemic condition, cars are gradually becoming a necessity. It becomes crucial for an automotive owner to be able to prevent theft of their vehicles. Some individuals only lack a garage to store their vehicle in for those occasions when they have their car in an unknown location. Other requires a security location. Also, we have another case study, analysis of IoT-based vehicle anti-theft security. This case study analyzes the need and importance of IoT-based anti-theft system. This case study deeply inspects and proves that the vehicle manufacturer's security mechanism is not enough to protect a vehicle from being stolen. Also, we have another case study, an attempt to develop an IoT-based vehicle security system. The system proposed a different method rather than providing location for the vehicle. If an authorized person attempts to start the ignition of the car, the system would send an SMS, then the user cloud reply with another SMS to command the vehicle to stop the ignition, therefore preventing the vehicle from being stolen. This project presents a message sending module that takes advantage from the GSM. Also, the current system, after interviewing vehicle owners and analyzing and reviewing the current system, it was found that the existing IoT anti-theft system and method available are somewhat inefficient. They lack accuracy when contacting the law enforcement agencies. This is because of one or more of the following 3 reasons. Because most of the current system works individually, their feature does not work as a complete security solution. None of the existing system could contact the owner by 2 different technologies. None of the existing system could give the owner to the ability to contact law enforcement agency. Also, I have another reason, which is some of the existing system requires a confusing and difficult process of installation. Also, now I will make a comparison between the current system. So these are the features on my left, and on my right we have the current system, current case studies. So case study 1 and case study 2 has GPS, but case study 3 and case study 4 don't have GPS. So case study 1 has GSM, but case study 2 don't have GSM. Case study 3 don't have GSM, and case study 4 has GSM. So case study 1, 2, and 3 don't have control the engine, but case study 4 can control the engine. Case study 1 and case study 3 can contact the owner and can't contact the owner, and case study 2 and case study 4 can contact the owner. And case study 1, case study 2, 3, and 4 can't report the police. Also, we have some main components for the system. Also, we have many other components, but now I will talk about the main component. So the first one is the breadboard. It's used to connect the different hardware components together. A breadboard to connect Arduino and read switch as well as the sensors together. Also, we have GPS Neo 6. This allow for a through satellite search. Also, we have SIM 800L. So this tool is used to read the SIM card and it's responsible for sending SMS message in case the car was being stolen. Also, we have EPA32. This tool is a microcontroller by Arduino, which is an open source electronic technology used to implement both hardware and software to read input from different sensors and devices. Also, I made a Gantt chart for my FYP1. So from the October, we did the proposal and we choose a title. After that, from the November to the end of January, we did chapter 1, chapter 2, chapter 3, chapter 4, and chapter 5. And now we have the final review. So now I will talk about my use case diagram for this system. So we have a scenario. We have three actors: vehicle owners, law enforcement, and admin. So the three of them can log in and log out. So first of all, vehicle owners log in. After first of all, he or she will register. After that, will log in and utilize GPS, and after that update account information and can delete account information. After that, if the car will be stolen, he or she will receive a notification, a saved notification. So he or she can send this saved case to the law enforcement. So once he or she, I mean the vehicle owner, sends a theft case to the law enforcement, the location of the car, I mean the map, will automatically share with the law enforcement. So the law enforcement will receive the notification and also respond to the saved case. After that, track the vehicle through GPS and view user account. Also, we have the admin. The admin can manage user account, can manage GPS track, can manage push notification, also can install new GPS track to the system. Also here we have architecture design. We have three users, which is vehicle owner, admin, and law enforcement agency. The three of them can use mobile or computer, and they can use internet because the system needs to have an internet connectivity. So the data will go to the server. After the server will receive the data, the server will send the data to the database, and the database will send data back to the server. Also, we have a UML class diagram. So in the UML class diagram, we have data, we have person, owner, vehicle, location, notification, law enforcement, and both of them and all of them are connect with each other and send data and receive data together. So here we have sequence diagrams. The first sequence diagram is register. It's for vehicle owner. After the vehicle owner opens the application, he or she can enter the information, which is the username and password, and it will send to the database and will make an account for the user. Also, we have another sequence diagram for vehicle owner, which is utilize GPS. After access and gain access, the data will request to the server and also to the database. The database will get the location of the data and will get the request of Google Map, and after that, the display of map will go to the user and will end. Also, we have another sequence diagram for the vehicle owner, which is update account. The user can update account based on based on her or his information, and after that, the new information will save into the database, and the account will be updated. Also, we have another sequence diagram for vehicle owner, which is delete account. The vehicle owner can delete his or her account, and after pressing the delete account and delete information, the request delete account will go to the database server and the account will be deleted. Also, we have another sequence diagram for vehicle owner, which is receives the safe notification. When the safe installs the vehicle, the admin will send the safe notification to the user or to the vehicle owner automatically, and the vehicle owner will see the notification on the system. And we have another use case diagram for submit saved case. After the vehicle owner will receive the safe notification, he or she can make a report and send it to the law enforcement. And here we have a sequence diagram for law enforcement to respond for theft case. After the vehicle owner will send the theft case to the law enforcement will receive the theft notification and respond for this case. Also here in the sequence diagram, the law enforcement will track the vehicle through GPS. So the admin will send the Google map, and then and first of all, the law enforcement will request for the Google map, and the admin will send it. And after that, the law enforcement will get the Google map, and the sequence diagram will be finished. And here in the sequence diagram, it's for view user account for law enforcement. So here, basically, the law enforcement can see the user information after the admin will send the permission for viewing account to the law enforcement. And here we have a sequence diagram for admin, which is manage user accounts. The admin can get data request and can update the vehicle owner account based on his or her information. And here we have another sequence diagram for admin, which is manage GPS track. So the admin can manage the detail of GPS track, and then it will be updated in the database server. Also here we have another sequence diagram for admin, which is manage push notification. So the admin will request to access the notification and manage notification, and then the database or server will generate notification. And the conclusion, the achievement, we understood the needs of the proposed system, now have a good grasp of our system and how we should implement it. And the objective to analyze and review the existing and current anti-theft warning system. We explored the existing system, took feedback from users, and understood their flaws. This helped us better understand with its lacking in the community and what we can do to fix it. Also, to design and develop a proposed IoT-based system. While it's not fully achieved, we understood how our system should work and interact with the users. Then we also designed the interface, which gave us a head start on what the system would look like. So thank you so much for listening. I hope you enjoy everything. I hope you enjoy, and everything will be will clear. And I will looking forward to meet you, my supervisor, my evaluators, and my coordinator face to face, and to discuss this project with them. I will be looking forward to your feedback. Thank you very much for listening, and have a good day.